In this video, I'll show you how to solve this algebra problem. Now, when facing this type of problem, your first step is see what sign you have. What we have is addition. We have addition. Now, what's the second step? What you have to do is, when we're given a problem like this, we have to factor as many things as we can. So what I mean by that is, let's first take x plus 6. Can that be factored? No, it cannot. X plus 6 is in its final form. Now, is x squared minus 3x minus 10? Can that be factored? Yes, it can. This will become x minus 5 times x plus 2. That is equal to x squared minus 3x minus 10. Next, x plus 3. Can that be factored? No, it can't. X plus 3 is in its final form. Finally, x squared minus 4. Can that be factored? Yes, it can. This becomes x minus 2 times x plus 2. So now, once you've factored everything in the equation, what you have to do is you now incorporate your sign. Because depending on what sign is given in the problem, you would say multiply accordingly or add certain factors. But here we have addition. And in addition, what we have to do is we have to create a like denominator. So make a like denominator. And the way you do this is you take whatever. Let's take our fraction, our denominator on the left side, x minus 5 times x plus 2. So x minus 5 times x plus 2. Now let's take our fraction on the right. We have x minus 2 times x plus 2. Do we have anything common in there? We do. So let's go ahead and just put something under it to signify that it's already there. And now all we have to do here is x minus 5 is not in the right equation, and x minus 2 is not in the left equation. So all we do to make them equal is we simply tag on x minus 2, and then we tag on x minus 5. Now we can go ahead and read it out. Is x minus 2 in the left, and is x minus 2 in the right? It is. Now is x minus 5 in the left? Is x minus 5 in the right? It is. And then x plus 2 is in the left, and x plus 2 is in the right. So now we've created a completely equal denominator. Now, but there's one catch. You can't simply just add stuff to the denominator, because if you only add things to the denominator, the fraction would be completely changed. So that's why I put it in a different color, because it shows which one we added and which one, which segment we added to a certain fraction. So on the left fraction, we added x minus 2. And whatever we do to the denominator, you must do to the numerator as well. So if we multiply by x minus 2 on the left side denominator, we have to do x minus 2 on the right side numerator. Now on the right, we did multiplied by x minus 5 in the denominator, so we must do the same in the numerator. So x plus 3 times x minus 5. Now that we have just quick thing, notice how the fraction will be the exact same. Because just remember, you must do the exact same thing to the numerator as you do to the denominator. Now, once you've done this, go ahead and put this all under one fraction. I like to write it out because it just helps. It helps with solving. So I do x minus 2 times x plus 6 plus x plus 3 times x minus 5. And the reason that you write all of this in parentheses is because that shows that it's a separate segment, and they're not just adding x and adding 6 to the total. Because if you were to take those apart, then you wouldn't get the correct solution. Now, all we have to put this under, you put this under, and remember we created a like denominator, so we just put that here. It's x minus 5 times x plus 2. Now, whenever you reach, or once you've reached this step, which is you got everything under one denominator, and you've put everything into one numerator, what you want to do is you want to check if your question is asking you to find restrictions, because this is also restrictions is also part of this. It comes with this problem. So if the question is asking you to find the restrictions, that's where you would write your restrictions down at this step, because you haven't canceled anything out yet, and it's just easier to grasp. So restrictions is simply just what x cannot equal. And what I mean by what x cannot equal is you can never divide by 0. So if any one of these segments here, if any one of these segments in your denominator, any one of these segments in denominator was equal to 0, then we would get this numerator divided by 0, and that would be undefined, and that can't happen. So that's what I mean by restrictions, and these restrictions are in place so that way you get like monetary value. It's not just undefined. So what your restrictions would be is put restrictions equal to x cannot equal to. What you would do is you would take each of these segments in parentheses. So what I mean by segment is just x minus 2 is one segment, x minus 5 is one segment, x plus 2 is one segment. What you would do is you would set each of these segments separately equal to 0. So we'll do x minus 2. We'll do x minus 2 is equal to 0. Then x minus 5 is equal to 0. And then x plus 2 is equal to 0. What we do here is, all we do is add 2 to both sides. X equals 2. Add 5 plus 5. X equals 5. And minus 2 minus 2. Then you get x equals minus 2. And these three numbers, or however many segments are in your denominator, those numbers will be your restrictions. So your restrictions are x cannot equal 2, 5, negative 2. And if you're just a little confused, you can go ahead and plug it in. We have, if x equals 2, plug it in here. 2 minus 2 is equal to 0. X equal to 5. 5 minus 5 is equal to 0. And minus 2 plus 2 is equal to 0. So that's just the first part of finding the restrictions. Now this is where you proceed to find your final answer. And what you would do here is, this is actually quite simple. Once you got to the step, it's pretty self-explanatory. So all you have to do is, you would multiply each of these. So what's x minus 2 times x plus 6? You would get x squared here. You get x squared plus 4x minus 12. And then this would be plus, what's x plus 3 times x minus 5? X squared minus 2x minus 15. And now we can go ahead and add all the like terms. Well, this is technically all over x minus 2, x minus 5, x plus 2. And let's just go ahead and add everything in our numerator. All the like terms. So this would become x, we have 2x squared, so x squared plus x squared. X squared plus x squared equals 2x squared. And then 4x minus 2x plus 2x. And then minus 12 minus 15 minus 27. And this is all over, once again, x minus 2, x minus 5, and x plus 2. So I'll just go ahead and erase that. And now, what do we do from here? What we have to do is we take whatever quadratic we got in the numerator, we would just factor that. So what's 2x squared plus 2x minus 27? What's that? What's that factored? Well, can this be factored? And really, it can't be. So 2x squared plus 2x minus 27 cannot be factored. So what do we do in this scenario? What we have to do is we just simply take this, and because it can't be factored, our final answer would be 2x squared plus 2x minus 27 divided by x minus 2 times x minus 5 times x plus 2. Hypothetically, say it was factorable, which is more often it will be factorable, and then you would take all the factors or segments in your numerator, and then you would see if it's the exact same segment in the denominator, and then you would be able to cancel. But this is a viable answer as well. Thank you for watching this video. Be sure to like, subscribe, and watch out for future videos. Thank you.